Hey there, I'm glad you're here. This is Middle School Math with Dr. K, and today we're solving equations that involve square roots and cube roots. Let's do this. Leading into this video, hopefully you've become familiar with some of your perfect squares and the idea of a square root, as well as some perfect cubes and a cube root. What we're going to do today is focus on when do you use these skills and what kind of equations might you see that require them. This is one example of that, where we've got x squared is equal to 16. Now, what we should know already is that this equation is telling us that some number times itself gives us 16. Hopefully you're already thinking, I know what that number should be. But let's talk about algebraically what you do to solve an equation like that, because as they get more difficult, you'll need a process to work on developing an understanding of these equations. Now, when you see an x squared, just like in any other equation, you're trying to isolate that variable. You're trying to not have x squared, but just x. And to undo that squared, you need to square root. And just like any other equation, whatever you do to one side, you do to the other. Now, on the left-hand side, square rooting a square number is finding its original place. Think of it like this. If I was square rooting 25, I'm figuring out what times itself gave me 25. Well, I know that answer would be 5, right? If I square root x squared, I'm looking for what number times itself gave me x squared, and I know that has to be x. What I've just done is figured out that the square root of x squared is equal to x. On the right-hand side, I have to think about the square root of 16. So similarly, I want to know what number times itself gives me 16. In this case, 4 times itself gives me 16. What's interesting is there are two answers to this equation. Another answer would be that x is equal to -4. Now let's check those solutions and talk about why there are two solutions this time as opposed to just one. Remember that you can always check your solutions by plugging them back into the original equation. So, for example, if I plug 4 into the original equation, I would get 4 squared equal to 16, and I know that 4 squared is 16. That makes a true statement, which means it is a solution to my equation. Now, here's why this one has two solutions. Squared is equal to -4 times -4. And what happens when you have two negatives multiplied together? Well, as you know, we get a positive solution, so we get a positive 16. That means that when I plug in a -4, I still get 16. I still get a true statement. So -4 is also a solution to this equation. Remember that to be a solution, it has to be a number that you can plug in that makes the equation true. If I plug in a 4, I do get 16. If I plug in a -4, I also still get positive 16. Let's try another. Here we have x squared equal to 49. Just like in the last one, we're looking for two numbers that when we multiply them together, we get 49. Now, algebraically, how you solve an equation like this is you square root both sides. Now remember that when we square root x squared, we're looking for what number times itself gives us x squared. Well, I know that would have to be x times itself, right? So the square root of x squared is x. When I square root 49, I'm looking for what number times itself gives us 49. In this case, I know that 7 times itself gives us 49. I also know that -7 times itself would give us 49. So let's verify that these are the solutions to this equation. If I plug in a 7 to my equation, 7 squared is supposed to equal 49, and I know that is true, making 7 a solution to this equation. Now, if I plug in a -7, I know that -7 squared is equal to -7 times another -7, which does equal a positive 49, making it another solution to this equation. So our two solutions are that x equals 7 and x also equals -7. Now, once you've got the feel for using a square root in an equation, it's not hard to apply other equation solving skills to an equation with x squared. So here we've got 2x squared is equal to 288. Again, just like in any other equation, I really want to work on isolating that x squared, which means I need to get rid of this guy, the 2, the multiplier. Now we know from previous equations that in order to undo multiplying by 2, I need to divide by 2, and I need to do that on both sides to keep my equation equal. Remember, it's in balance, so if I divide the left side and I don't divide the right side, they're no longer equal. That's a problem. So I have to divide both sides. On the left side, 2x squared divided by 2 would leave me with 1x squared, or just x squared. On the right-hand side, 288 divided by 2 would be 144. Now, hopefully you already know where to go from here. I need to get x, not x squared, just x. So I'm going to square root both sides. Now remember that the square root is saying what number times itself gives me x squared. In this case, I know that I end up with just x. On the right-hand side, I'm thinking what number times itself gives me 144. Hopefully we know already that that's going to be 12. 12 times 12 is 144. And we should be getting a feel for the idea that there's a second answer. In this case, negative 12 times negative 12 also gives me positive 144. So I have two solutions. On the right-hand side, I have a similar type of equation. I'm still trying to get x squared by itself first thing, which means I need to get rid of that 15. Just like when we solved linear equations, we're going to subtract 15 from both sides to see where that puts us. I know that 15 minus 15 is 0, so on the left-hand side, I'm left with just x squared. On the right-hand side, 415 minus 15 is just 400. And now I need to get just x, not x squared, so I will square root both sides. I know that the square root of x squared is just x. And on the right-hand side, the square root of 400 is 20 and is also negative 20 because positive 20 times itself is positive 400 and negative 20 times itself is positive 400. Again, once we've got the general idea for using a square root in an equation, it's not hard to then adapt to the process of a cube root or a cube in an equation. So here I've got the equation 2x cubed is equal to 128. This time I've got x cubed that I'm trying to isolate. Otherwise, it's really the same process for solving. So I still want to divide by 2 on both sides. That leaves me with 1x cubed, or just x cubed, and that leaves me with 64 on the right-hand side. Now the difference between this equation and past equations is that now instead of square rooting, because I had x squared, I need to cube root. And we show that a little bit differently. We show it with a square root symbol that has this little 3 at the top to show that it's a cube root and not a square root. I'll do the exact same thing on the right-hand side. Now in this case, when I'm working with a cube root, I'm thinking what number times itself again, so 3 things that give me x cubed. And those 3 things would be x's, right? So the cube root of x cubed is just an x. Similarly, when I'm doing the cube root of 64, I'm looking for what number times itself again would give me 64. And I know that 4 times 4 is 16, times another 4 would give me 64. So the cube root of 64 is 4. Here's what's a little different about a cube root versus a square root. A cube root has one solution. It can't have 2 solutions, and here's why. When I multiply 4 times 4 times 4, this gives me positive 16, this gives me 64. Positive 4 is a solution. I have just verified it. If I tried that with negative 4 times negative 4 is still 16. That's still true. But when I multiply by another negative 4, I no longer get 64. I get negative 64. That tells me that negative 4 is not a solution because I'm not looking for my equation to equal negative 64. I'm looking for it to equal positive 64. This time, I only have one solution, and it's x equal to positive 4. Let's talk through a couple more examples of that. So again, I want to isolate this x cubed first, which means I need to get rid of that 4. Since 4 is being multiplied by x cubed, I need to divide by 4 on both sides. In this case, 4x cubed divided by 4 gives me 1x cubed, and on the right-hand side, 4,000 divided by 4 is 1,000. Just like before, I need to cube root. Be sure to put that little 3 right here. That shows that I'm not square rooting, I'm cube rooting to get rid of the 3 exponent. I want to do the same thing on the right-hand side to keep my equation balanced. Again, the cube root is asking what number times itself again gives me x cubed. In this case, it would be x times itself again. So on the left-hand side, I've got x. On the right-hand side, the cube root is asking me what number times itself again gives me 1,000. In this case, 10 times 10 is 100, times another 10 is 1,000. So the cube root of 1,000 is 10. Now remember that there is only one solution in an x cubed equation, and here's why. If I multiplied negative 10 and negative 10, that would give me positive 100. But if I multiplied by that third negative 10, I'd get negative 1,000. That would make my equation no longer true because I'm looking for it to equal positive 1,000, not negative 1,000. So here I've got my solution, x equal to positive 10. Let's try another. On the next one, I have negative 2 times x cubed equal to 128. Again, I want to solve to get that x cubed by itself. So hopefully you already know where I'm going with this. I'm going to divide by negative 2 on both sides, which leaves me with 1x cubed. On the right-hand side, it leaves me with negative 64. This one's a little different. We haven't seen a negative yet. When I cube root on the left-hand side, we should know that I get just x, because x times x times x is what gives me x cubed. When I cube root negative 64, it's a little different. Now, we should know that the cube root of 64 is 4, right? So maybe the answer is 4. Let's try that. 4 times 4 times 4 would give me a positive 64. That's not actually what I'm looking for. I'm looking for a negative 64. In this case, we can have a negative solution. It's just that we can only have one solution. So it's either positive or negative when you're solving a cube root equation. Now, negative 4 would give me positive 16, and then a positive 16 times the last negative 4 would give me the negative 64 that I'm looking for. So my solution here is negative 4. Here's one last example that I want to show you, and this is an example where there's a problem when you're solving. So let's jump in. First, I know that I need to subtract 15 from both sides, which isolates that x squared variable. Now, pay special attention when you're solving these to whether you've got a squared or a cubed, because that tells you whether you need to square root or cube root. In this case, I need to square root, so I'll square root both sides. I know that on the left-hand side, I'll get just an x, but something weird comes up when I'm square rooting a negative. So remember that the square root means, the square root of negative 16 means I need something times itself that would give me a negative 16. Well, I know that 4 times 4 would give me a positive 16, so it can't be 4. I know that negative 4 times negative 4 would give me, also a positive 16, so it can't be negative 4. This is an example of when there is actually no solution. You can't square root a negative because there are no two numbers that are exactly the same that will give you a negative. I know that two positives give me a positive. I know that two negatives give me a positive. There's no two numbers that are the exact same that will give me a negative. So this has no solution. So here's a big overview and something you might choose to write down in your notes. Square root equations have two solutions most of the time, and sometimes they have no solution. We just learned that you cannot square root a negative value. Cube root equations have one solution. And when you solve, dealing with the exponent should be the last step. That's the last thing you do. If you need to add or subtract, or you need to divide or multiply, those are the things you start with. Then you square root or you cube root. So I hope this leads you in the right direction for solving square root and cube root equations, and I look forward to seeing you next time. Thanks for being here.